Question 27. As shown in the diagram below, a mass m with charge plus q is sliding down the slope at constant velocity v. When the mass enters the region with the uniform electric field E, which of the following is correct? Let us discuss the case when the object has not entered the region with electric field. In this case, the mass m will experience its downward gravitational force, mg. Assume the slope makes an angle theta with the horizontal. We can easily see that the component of force normal to the slope is mg cosine theta, while the force component parallel with the slope is mg sine theta. This mg sine theta will accelerate the mass m in along the slope if and only if there is no friction, but since the mass m is not changing its velocity, there must be a frictional force in the opposite direction with equal magnitude. We can make use of this relationship to find out the coefficient of friction to be sine theta over cosine theta. Next, let us talk about what will happen when the object enters the electric field. Obviously, apart from the gravitational force, it will experience an additional downward electrostatic force, QE. We can subdivide the force components in a similar way, and you can see that the result is similar with the presence of additional term due to electrostatic force. This applies to friction too. There is an additional term, QE cosine theta. Now, let us expand the expression of the friction. Clearly we can see that the first term is equivalent to mg sine theta, according to our result in the previous part. For the second term, recall that the coefficient of friction is just sine theta over cosine theta, so we can also write the second term as QE sine theta. Compared to the force parallel to the slope, we can see that again they are equivalent to each other. As a result, the net force on the mass, m, is again 0 too. Thus the velocity will remain unchanged and the answer is A. Question 28 discusses similar scenario, but this time magnetic field is also present. By using left-hand rule, one can easily identify the direction of the magnetic force is opposite to the normal force the mass exerts on the slope. As a result, the net normal force will decrease, and this also implies the friction will also decrease. Hence the net force on the mass m is no longer 0. This means that the mass m will accelerate when sliding down the slope. Thus, the velocity will increase and the answer is B.